Hello students, welcome to this video. In this video, we will start mathematical induction, theory and solve 10 more problems as there is not much theory to this. Okay, so we'll quickly cover the theory and solve 10 problems. The link to download the PDF will be in description, as well as at the end I will show you how you can download the books I have written, and also I will show you my website where you can come and ask questions related to mathematics. So let's get started. We read the theory, but we can read the first paragraph. It doesn't matter. All this is basically story. So the important part I will read is any reasoning involving passage from particular versions to general versions which derive their validity from the validity of particular versions is called induction. Mathematical induction is a mathematical proof technique which enables us to draw conclusions about a general law on the basis of particular cases. In Boolean algebra, a statement which is either true or false, this should be or, is called a proposition. Pn will denote a proposition whose truth value depends on natural numbers. For example, we recall the sum of first 10 natural numbers from arithmetic progression is and n to n plus 1 by 2. This can be written as Pn. We can write Pn is equal to 1 plus q to n. So here P2 is 2 means sum of first two natural numbers is equal to 1 plus 2, that is 2 into 3 by 2 is equal to 3. So there are two forms of mathematical induction. One is finite mathematical induction. The proposition Pn is assumed to be true for all natural numbers if the following two conditions are satisfied. Pn is true for n is equal to 1, that is P1 is equal to 2. Pn is true implies that Pn plus 1 is true where n is an arbitrary natural number. So if we can do this, then it is Pn is assumed to be true. The extended form says that Pn is a proposition such that P1, P2 through Pk are true. Pn plus 1, Pn true, Pn plus k minus 1 are true implies Pn plus k is true. If Pn is a proposition such that Pr is true, then Pr plus 1 through Pn implies are true implies that Pn plus 1 is true. It should be space here, and it shouldn't be italic. Looks like they went inside the match mode. Okay. So now we solve the problems. So mathematical induction is quite fun. Okay, it is a simple stuff, so you should get good grasp of this. The first question says that show that 1 square plus 2 square through n square is equal to n into n plus 1 into 2n plus 1 by 6. So we let n is equal to 1. We see p1 is equal to 1 square on the left hand side, and right hand side will be, we substitute n is equal to 1, we get 1 into 2 into 3 by 6. So which is equal to 1, so p1 is true. We let it is true for n is equal to k. Then for n is equal to k plus 1, we write left hand side is 1 square plus 2 square up to k plus 1 whole square. And right hand side will become k into k plus 1 into 2k plus 1 by 6, because it is true for n is equal to k, and then we add k plus 1 whole square. And then we solve the right hand side. So upon solving the right hand side, we get k plus 1 into k plus 2 into 2k plus 1 2k plus 3 by 6, which is pk plus 1. And thus it is true for n is equal to k plus 1, and thus by mathematical induction we have the result. Question 2 says that so that 1 by 1 times 2 plus 1 over 2 times 3 and so on up to 1 over n times n plus 1 is equal to n over n plus 1. So we take n is equal to 1, it becomes 1 by 1 into 2 on left hand side, and right hand side is 1 by 1 plus 1, which is equal to left hand side. So P1 is true for n is equal to 1. Okay, we let it to be true for n is equal to k. So Pk is equal to, we do the same thing up to 1 by k into k plus 1 is equal to k by k plus 1. This is what we let. Now we add 1 by k plus 1 times k plus 2 on both left hand side and right hand side. On right hand side, we solve this, we get to the solution as k plus 1 by k plus 2. is equal to pk plus 1, and hence by mathematical induction we have the result. Question 3 says that show that 1 cube plus 2 cube through up to n cube is equal to n times n plus 1 over 2 whole square. So when we substitute n is equal to 1, left hand side is 1 cube, right hand side becomes 1 into 2 by 2 whole to the power 3, which is equal to 1. So Pn is 2 for n is equal to 1. Relate it to be 2 for n is equal to k, and thus we have this, and we add k plus 1 whole cube to both sides. So right hand side we solve, and we get it equal to k plus 1 times k plus 2 over 2 to the power 2. So which is equal to pk plus 1, and hence by mathematical induction we have the result. Question 4 says that we have to show that 1 over a plus b plus a divided. Okay, this might have a. So 1 by a plus b plus a by a plus b times a plus 2b up to a by a plus n minus 1 into b times a plus nd is equal to m by a plus nd. Okay, so we let n is equal to 1. So p1 is equal to 1 by a plus b, and that one side is also 1 by a plus b. So it is true for n is equal to 1. We let it be true for n is equal to k. So we simply substitute n is equal to k. We arrive at this relationship. Okay, this relationship here. And then we add a by a plus kd times a plus k plus 1d to both sides. So this becomes our left hand side, and then we solve the right hand side. We get right hand side eventually as k plus 1 by a plus k plus 1 times d, which is equal to pk plus 1, and hence by mathematical induction we have the result. So as we see by now that the questions are fairly easy. Well, it is quite easy to solve these problems. Question 5 says that show that 1 by 1 times 2 times 3 plus 1 over 2 times 3 times 4 up to 1 over n times n plus 1 times n plus 2 is equal to n times n plus 3 over 4 times n plus 1 times n plus 2 for all n natural numbers. So we first put n is equal to 1, left hand side becomes 1 by 1 into 2 into 3, and right hand side is 1 into 4 by 4 into 2 into 3, which is equal to 1 by 2 into 3. Now this is true for n is equal to 1, we let it be true for n is equal to k, so we substitute n is equal to k here, and we have this relationship. Now we add 1 by 1 over k plus 1 times k plus 2 times k plus 3 to both sides. The left hand side will be the form of pk plus 1, and right hand side we solve. We get k plus 1 times k plus 4 over 4 times k plus 2 times k plus 3. There should be single plus, which is equal to pk plus 1, and hence by mathematical induction we have the result. Question 6 says that so that 1 times 3 plus 2 times 3 square plus 3 times 3 cube up to n times 3 to the power n is equal to 2n minus 1 times 3 raised to the power n plus 1 plus 3 over 4. So first we put n is equal to 1, left hand side is 1 into 3, and right hand side we put n is equal to 1, we get 2 minus 1 into 3 square plus 3 by 4. So 2 minus 1 will be 1, and 3 square will be 9 plus 3 12 by 3 4, which is 3. So it is 2 for n is equal to 1, we let it be 2 for n is equal to k. So we add k plus 1, 3 raised to the power k plus 1 to both sides. The left hand side takes the form of pk plus 1, and right hand side we solve. On solving the right hand side, we get it as 2k plus 2 minus 3 times 3 to the power k plus 1 by over 4, which is equal to pk plus 1. Okay? So we can solve, we can arrange this and see that it will come in this form. Okay? So with this, we have proven this by mathematical induction. Now we come to question 7. Question 7 says that show that 1 plus 4 plus 7 up to 3n minus 2 is equal to n times 3n minus 1 over 2. So again we put n is equal to 1, left hand side is 1, right hand side is 1 times 3 minus 1 by 2, which is equal to 1, and thus Pn is true for n is equal to 1. Now assume that n it is true for n is equal to k. So we substitute n is equal to k, we get pk. Now we add 3k plus 1 to both sides. Left hand side takes the form of 2k plus 1, and we solve right hand side, and it eventually becomes k plus 1 times 3 times k plus 1 minus 1 over 2, which is of the form pk plus 1, and hence by mathematical induction we have the result. Question 8 says that show that 1 square plus 2 3 square plus 5 square through n to n minus 1 whole square is equal to n times 2n minus 1 times 2n plus 1 by 3. To proceed similarly, we substitute n is equal to 1, we get p1 is equal to 1 square is equal to, we substitute here 1, but this is not called, this is 1 times 2 minus 1 times 2 plus 1 by 3, which is equal to 1, so it is 2 for n is equal to 1. We let it is 2 for n is equal to k, so we substitute n is equal to k, we get this form. When we add 2k plus 1 whole square to both sides, left hand side assumes the form of k plus 1, and right hand side, if you see this solution, we see that it takes the form of k plus 1 times 2k plus 1 times 2k plus 3 by 3, which is of the form pk plus 1. So what we need to do here is, we look carefully, this is 2 times k plus 1 minus 1, okay, this 2k plus 1 is that, okay, and 2k plus 3 is 2 into k plus 1 plus 1. That's how it is proven by mathematical induction. Question 9 says that show that 1 minus 3 square plus 5 square minus 7 square up to 4n minus 3 whole square minus 4n minus 1 whole square is equal to minus 8n square. So we let p n is equal to 1, so p1 is equal to 1 minus 3 square, that is minus 8, which is minus 8 into 1 square, we let it be 2 for n is equal to k, so we have this form. Now we add 4k plus 1 whole square minus 4k plus 2 whole square to both sides. The left hand side takes the form of pk plus 1, and right hand side becomes minus 8k square plus 4k plus 1 whole square minus 4k plus 3 whole square, which eventually becomes minus 8 into k plus 1 whole square, and hence by mathematical induction we have the result. Question 10 says that show that 3 times 6 plus 6 times 9 plus 9 times 12 up to 3n times 3n plus 3 is equal to 3n times n plus 1 times n plus 2. So we let n is equal to 1, we get left hand side as 3 into 6, and right hand side becomes 3 into 1 times 1 plus 1 times 1 plus 2, which is essentially 3 into 6, and thus Pn is 2 for n is equal to 1, we let that it is 2 for n is equal to k, we have this form. Then we add 3k plus 1 times 3 times k plus 1 plus 3 to both sides, so we get left hand side takes the form of pk plus 1, and right hand side, if we see, it becomes 3 times k plus 1 times k plus 2 times k plus 3. Okay? So that is what we have to prove. Yeah. So which is of the form pk plus 1, and thus by mathematical induction we have the result. With this, we come to the end of first 10 problems of mathematical induction, and in the next video we will solve 10 more problems. Now I'll show you how you can download the book. You can go to westlock.org, download the algebra, trigonometry, and trigonometry books from 2nd, 3rd, and 4th link. These will not contain date, so you need to update the date. And after 15 or 30 days, you can come back and check if a new version has been released. If a new version has been released, you can download it. I do not put date in the actual files, because if I do that, I will have to update all the links on YouTube, which is practically infeasible. Also, that will make the old links invalid if somebody has shared it to someone. So that is no good for practical reasons. Now I will show you my question answer website. You can come to pundika.westlock.org. You can ask mathematical questions here, because YouTube is not suitable for mathematical discussion. You can make a login by registration. Click a username, email, you'll be sent a confirmation email link. Click that link. Your email will be confirmed, and then you can login. For login, you type your email, and you will receive a code. Paste that code in the next field, and you will be logged in, and then you can ask questions here. So the tags which you can use for math are algebra, calculus, geometry, trigonometry, and probability. If you need more tags, add use tag Pumrika and make a future request, and I'll add more tags if you need those. Okay. For example, if you need tag of set theory or vectors, I'll add those as well. So with this, I will end this video here. I hope that you are enjoying this playlist. If you have not watched other videos in the playlist or you are new to the channel, make sure you watch the playlist from the beginning. And there will be a lots of questions if you watch those. And there is definitely something you can learn if you are a class 12 student. So I wish you all the very best and keep learning. I will see you tomorrow with 10 more problems on mathematical induction. I will take my leave here. So have a great day and sayonara.